Hey guys, today I'm going to teach you all about ratios and rates. By the end of this lesson, you'll be able to find unit rate and understand its uses to compare and predict quantities like speed and price. So go ahead and get out your binder, turn to the math section, and get ready to take some notes. Let's get started with a review of something that we should already know, and that's ratios. A ratio is just a comparison of two numbers. We can write ratios three different ways. If the ratio was 3 to 2, we could say 3 to 2. We could say 3 with the colon 2. And then we could also say 3 over 2. Those are all three different ways to write ratios. So ratios are basically just fractions, but the order in which you write the ratio is important to the meaning. Ratios, like fractions, can be simplified. So let's practice with this picture here. It says use the pictures below to practice writing ratios. So you can go ahead and fill this out. I'll go ahead and do the first one for you. It says teeth to no teeth. So I want to go through and circle all of the smiley faces that show teeth. I count 9 to 15, so we can write 9 to 15. But like we just saw, ratios are like fractions. They can be simplified. So I can write it 9 to 15 like that, or I can write it 9 over 15, which is the same thing as 3 to 5. Remember, the order matters because when I say teeth, I'm talking about the first number. To no teeth, I'm talking about the second number. So the order is really important here. If you can, I would simplify your answers. So like I said, take a second to go through here and figure out all the rest of these boxes, and then I'll just go over them quickly after you've tried them by yourself. So pause the video, try these out, and then press play when you're ready to check. Okay, so I just went through, and I wrote it three different ways. Sometimes I wrote the colon, sometimes I wrote it with the word two, and sometimes I wrote it as fractions. It's okay if you didn't realize what like the silly face was or the angry face was, or you didn't know what was what, if it was a tongue or not. That's okay as long as you understand, like we put up here, that a ratio is a comparison of two numbers. You can write it as a fraction. You can write it with this colon. You can write it with the word two. You know you can simplify them because fractions can be simplified. We see ratio in the word rational number. That's why we know rational numbers are fractions, decimals, and integers. So when we get into rate, rate is a specific type of ratio where it's a comparison of two quantities with different units. So it's a specific comparison of two quantities with different units. That's what's important here. So you see examples of rate when we're talking about miles per hour, like how fast a car goes. We could say mph to denote that. You could also write miles per hour. You could write it as a fraction like that. So we see miles per hour as one of the most common rates. When you're looking at vehicles, you might also hear about miles per gallon. That might be an important reason you get a car over another car is how many miles per gallon it gets. We also might see something like dollars per ounce or price per ounce when we're talking about unit rate between two things you're looking at in a store. So if you're looking to buy two different types of cereal, for example, you might want to see how much it costs per ounce. Sometimes you see this whenever there's like a big box of cereal, like a 32-ounce box for a certain price, and then a 16-ounce box for a certain price, and you might want to compare and see which one's the better deal. That would be an example of using rate. So we said dollars per ounce. That could also go for dollars per unit. So dollars per any one unit. That is an example of a rate. So here's a real life example of a use of rate. Hunter jogs 4 miles in 30 minutes, but Ryan jogs 7 miles in 48 minutes. What is each person's speed? Who jogs faster? So they ran a different amount of miles in a different amount of time, but because we know about rate now, we can compare these two runners. The way I do that is to write a ratio comparing if it says like Hunter ran 4 miles, I would write 4 miles per 30 minutes. Remember, it's miles per minute. I know that this line means divide. So when I divide that, I know that I get 0.13 with a repeating 3. So I put that little line over top of it. So 0.13 miles per 1 minute. That's how you could write this as a rate. Ryan, on the other hand, jogged 7 miles per 48 minutes. Go ahead and try to simplify this by using our strategy where we are dividing 7 divided by 48 to figure out how many miles per 1 minute. So if you divided that correctly, you should get that Ryan ran 0.146 miles per minute. And I wrote MPM. You could write it like this. You can write miles per minute, however you want to write it. But either way you look at it, Ryan ran faster because he did it. He did more miles in 1 minute than Hunter did. So Ryan did more miles than Hunter did in 1 minute. So that example with the joggers is an example of a unit rate. When we find out how much per one unit, we are finding a unit rate. So the unit rate can help us determine the better value for our money also. So in the last example, it showed us who ran faster, so it let us compare. We can also compare value. So for example, a 12-pack of Orange Crush is priced at $3. However, a 6-pack is priced at $1.75. Which is the better value? Which is the better deal? There's a few different ways you can look at this problem, but since I want to know which is the better value, I want to know what is the price for one can? How much does one can cost for each pack? So to do that, I'm going to look at the price per can. The 12-pack is $3 per one can, so like a ratio, it's very important that you order the numbers correctly. I want to know the price per one can, so price goes on top, cans go on the bottom. When I divide that out, I get 0.25. In context, that means 25 cents per one can. So the 6-pack, on the other hand, is $1.75. So $1.75 per 6 cans. I'm going to divide that out, and I get 0.29 or 29 cents per one can. When I look at these two comparisons, now I can see that this is the better deal because it's cheaper per one can. So even though it's cheaper by only 4 cents, that's still a deal. And when you're looking at this in real life, instead of buying two 6-packs, you would just want to go ahead and get the 12-pack here. So using unit rate, we can determine the better value for our money. So when two ratios or two rates are equal, we have a special word for that, and that's called proportional. So when you see proportional, you should think equal. When you want to solve a proportion, one way is scaling. The way I focus on is cross multiplication. Let me show you an example of what cross multiplication looks like. Here's an example of two fractions or ratios that are equivalent and proportional. So those mean pretty much the same thing. Here's how you can prove that. Now, you might hear you call it the butterfly method. You might hear me call it cross multiplication. I'm going to stick with cross multiplication for now, but if you want to remember this, like the butterfly method because it'll look like a butterfly. So what I do is I always take the cross products of the numbers that are across from each other. So cross products means times. 5 times 2 is 10, and then I can divide by either one of these numbers to get the other number. So I get 5 times 2 is 10, divided by the 10 here gives me 1. Here's another set of equivalent fractions, and therefore they are proportional fractions. And I'm just going to show you this butterfly method another way. This right here, 8 times 3 is 24. So 8 times 3 equals 24. That means that this right here should also equal 24. 6 times 4 is also 24. They're equal, so they are proportional. This is called the butterfly method because it makes a little butterfly here. But I'll also, like I said, call it cross multiplication. The reason that this butterfly method or this cross multiplication is useful is because we can solve for missing values in a proportion. So I know these two fractions are equal. I know that they are proportional. So I know they're equivalent. What I can use is my butterfly method or my cross multiplication. So what I do is I multiply the two numbers that I have. Step 1, multiply the two numbers across from each other that you have. So for example, I can't multiply this way because I don't know what this missing number is. That's what I'm trying to solve for. So I multiply across. 18 times 2 is 36. And then the rule is I want to divide by the number that's left. 36 divided by 9 is 4. So I just found the missing value that goes here to make this equivalent. To check, I'll use that butterfly method again. 2 times 8 is 36. And now 4 times 9 is 36. So I know that both ways I get 36. Using cross multiplication or the butterfly method, I can prove and solve for equivalent proportional ratios. Sometimes they won't be perfect. So let's look at an example of one where it won't be perfect. I want you to take a second and think about which two numbers I should multiply first. So you should have thought about this and realized the two numbers that are across from each other are the 5 and the 3. So I cross multiply. So 5 times 3 is 15. I want to know what goes in this blank spot. So I need to divide by the number that I have left. That's the 4. So I'm going to divide by 4. 15 divided by 4 is 3.75 or 3 3/4. So you can just pick a way to write it either as a decimal or a fraction. You're going to want to fill it into that spot. Or if this was a variable, like let's say it's x, that just means a letter that stands in for a number, an unknown number. So you would write x equals 3.75 or x equals 3 3/4. I would encourage you to always check your answers we know 3 times 5 is 15. And so this times this should also be 15. So I just checked with a calculator, and 4 times 3.75 does equal 15. So no, I'm correct. So we just got a quick lesson on solving proportions. So let's go ahead and apply that to a real-world situation. A small university enrolls in-state and out-of-state students. So if you go to college, let's say you go to the University of Kentucky, you're from Kentucky, you're in-state. If you're from somewhere else like Chicago or New York or California, if you're from somewhere else out of state, you would be an out-of-state student. It says the number of students enrolled in their most recent freshman class was 243. The school reported that it enrolled 7 in-state students for every 2 out-of-state students. How many of each type of student was enrolled in the freshman class? So below, you have the chart. We should have gotten used to filling this out by now. We want to start with what we know. Then we move on to what we need to know. We know that there's 243 students in total, that there's 7 in-state for every 2 out-of-state. So whenever you hear something in the word problem that says something for every something else, you're looking at a ratio. So if I wanted to make a prediction or compare the ratio for in-state for every out-of-state, I could write that 7 to 2. You could also write it comparing the part to the total. So if I wanted to look at the in-state ratio to the total, I would write 7 to 9. And for the out-of-state ratio, I could write that 2 for every 9. So remember, 9 being the total. Depending on how you want to look at it, you can compare 3 different ways. But since the question is asking how many of each type of student was enrolled in the freshman class, I need to know about the total. So I need to use that 9 total. So when I look at my plan and my work, I'm going to use this big box. I'm going to compare the 2 ratios for in-state and out-of-state. Starting with in-state, I know that there are 7 in for every 9 total. I know that I want to use total instead of the 2 because I'm looking for how many of each type was in the total freshman class. So my equivalent ratio has to have matching units. So since there was a total group of 243, that's what I will write in the bottom of my new proportion. So all I'm doing here is setting up a proportion. So I'm setting up 2 ratios or 2 fractions that are proportional by making sure that they match on the bottom. So the ratio is 7 for every 9, 7 in-state for every 9 total. So my new one should match. Go ahead and take a second and try to solve this using our cross multiplication. So when we do cross multiplication, we multiply the 2 numbers we have across from each other, in this case 243 and 7. I got 1,701, and then I divide that number by 9. I got 189. So that goes on the top of the new fraction. So 189 is my answer for in-state. So there's 189 in-state students in this freshman class. You should always take a step back and think about that and see if that makes sense in terms of your problem. There's more in-state than there are out-of-state. 189 is kind of a big number, and it's pretty big compared to 243. You also want to check your answers. 7 times 243 should be equivalent to 9 times 189. They are, so I know that I'm correct. So now we'll do the same thing with out-of-state. Go ahead and set up your proportions, and then press play when you're ready to check. Okay, so you want to start with the ratio that you have. You have the 2 out-of-state for every 9 total. And you are trying to set up another ratio to figure out how many out-of-state are actually out of the 243 total. So this is your proportion set up. If you haven't already, go ahead and cross multiply to solve. You should have started with 2 times 243. I got 486, and then I always want to divide by the number that's left. So 486 divided by 9 is 54. That means that there are 54 out-of-state students in the freshman class. You always want to cross multiply again to check your answers. This across should equal the 2 times 243. Whenever it checks out and it does, you know you're correct. And I know some people are probably thinking, well, how come since I knew my in-state, I didn't just do 243 minus 189? You could, and if you did, you'd get the same answer. So in this last box, I just put my solution. I know there are 189 in-state students and 54 out-of-state students enrolled in the freshman class. All right, guys, that's it. If you made it to the end of this video, please put your favorite scary movie in the comments. Today we went over ratios and rates, so now you should be able to find unit rate and understand its uses to compare and predict quantities like speed and price. We also solved proportions using the cross multiplication method and checked with the butterfly method. They're both the same thing. Now you should go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye.